All right, so let's begin chapter 5. What you are going to learn in chapter 5 is you're going to learn about polynomials. This is very important for all the rest of your math classes. You're going to be working with polynomials next year in grade 10, in grade 11, pre-calculus, in calculus. Very, very important. Foundations math, whatever math you end up taking in high school and beyond, you're going to need to understand these important concepts. So you will learn to recognize, write, describe, and classify polynomials. Use algebra tiles, pictures, and algebraic expressions to represent polynomials. You're going to learn strategies to add and subtract polynomials and strategies to multiply and divide polynomials. So those are the high-level goals for this chapter. If you want, when you're studying or as you go through, you can come back to this page and check off the box when you think, hey, I've covered that. I think I know how to do all that. You can check that off as part of your studying. You can say, oh yeah, I've got this covered. Also, I've given you some keywords, so feel free, please, to write the definitions for these terms on this front page if you want, so you have them all together. It's a good spot for it. I left you a little bit of room to do that. And also, as I mentioned before, you do get a cue card for your exam, so I would suggest that you jot down any notes or diagrams or things to help build your cue card on this front page as well. All right. All right, let's get into this. Polynomial, okay. All right, we're going to fill in some blanks here. And yeah, if you have any questions as we go, feel free to ask, okay? So a polynomial, this is an algebraic expression. So this first space is the word expression. So you should have a pencil or a pen, pencil preferably, but you're going to write down expression that contains one term or a sum of terms. Okay? So in math, an expression is just a collection or a sum of individual terms. Okay? It can be one or more. It is important to note that an expression is different than an equation. Okay? So this has no equal sign. This is not an equation. So an equation has an equal sign, and we're talking just about expressions, which you will see an example below that we're going to sort of dissect a little bit. Okay. The term or terms may contain variables. Variables is what you want to put in this blank. Okay. Now variables would be letters, all right, in the expression. X is most common. Sometimes it's A or N or K or whatever. But the variable is, the meaning of the word variable is that it changes, okay? Or it's unknown and that variable can change in the expression, okay? So we'll get into lots more examples like that. But it'll have some kind of letter, a variable part. These variables may have a number exponents, okay? So it may have an exponent on there. That means, you know what the exponent is? It's the little number that kind of goes on the upper right corner, like a 2 or something, x squared. The 2 is an exponent, and we'll talk more about that later too. Okay, so it's an algebraic expression, a collection of terms. It's not an equation, it's just an expression, and it'll contain a variable of some sort, most likely. Okay. A term may be a number only. So most of the time you'll have some kind of variable, but the number 7 is technically a mathematical expression and is technically a polynomial. Okay, so the terms may have numbers only. All right, so let's take a look at this little part right here. All right, so this 3x, and I'll zoom in maybe on this a bit so you can see that a bit better. This 3x, okay, is our first term. Okay, so this is the first term in the expression, the 3x. And yes, this is 3 times x. And hopefully you know this already from math classes previous. This is 3 times x, okay? And that constitutes a term. This, the 1, is the second term, okay? So there are 2 terms total in this mathematical algebraic expression, okay? First term and second term. All right, the x we already discussed. The x is the variable here in this expression, so that's the variable. The 3, does anyone know what the 3 is in this expression, what you call it? Not quite. Good guess. Not the exponent. The exponent is going to go kind of in the upper right corner, like as a superscript, right? In the upper right corner. So an exponent on x, like x squared, this is the exponent up here. So I don't have that in this expression, but that's the exponent there. And a good idea if you want to just write that down in the margin for now if you want. But that's the exponent. So good guess. This is a really tough word. You don't hear, no, base, not quite. Again, this is the base for a power here. This is the base right here, which we'll talk more about those as well. There was another hand back there. You want to take a guess? No? Okay, it's a tough one. You may not have heard before. It's the coefficient. Coefficient. So the number that is multiplied by the variable is the coefficient. Okay. And this one here that does not have a variable, that's what we call the constant, okay, or the constant term. So in a mathematical expression, the part that has the letter that's multiplied in there, that is a term with a variable in it, and you could substitute any number in for x and get different values for this expression. So this term, technically right here, this little part of this term changes its variable. This term is always just 1. See, there's no changing part to it, so that's a constant term. Variable can change, constant remains the same. Questions? Right. All right, you guys are doing great, doing great. Okay, so 3x plus 1 is a polynomial. It contains a variable and it contains a number. So polynomials, again, can contain variables and numbers. Since it is an expression, as we mentioned, there's no equal sign. So let's make that official. I mentioned that before. But it's an expression and not an equality, so there is no equal sign. And we're going to get to equations for sure. We'll talk lots about equations, but for now, we're just talking about expressions. All right. This polynomial that we just took a look at has two terms. Two. A term is a number or a variable or the product. Now product, remember, means the result when you multiply. Okay, so from multiplication. So a number or a variable or the product of numbers and variables. Terms are separated by a plus sign or a minus sign. So different terms are added or subtracted together. So I'm just going to try and zoom in just a little bit more for you while still getting everything on. I just feel like, are you guys having trouble seeing, or can you see that pretty well in the back there? Okay, I have a couple hands up. Yeah. Did I miss something? Since it has two terms. Thank you very much. You're on the ball there. Good job. So that is two terms. Yeah. I think I saw to the corner of my eye this right here, and I thought, oh, two terms. Okay, you are correct. Someone's paying attention. I love that. Probably many of you noticed that. Good job. All right, so, and anything else here that we want to talk about? No? We're doing good? Okay. All right. Okay, so in the term 3x, 3 is called the what? Now you know this term. What's 3? Coefficient. Yeah, coefficient. Lots of repetition here, so you get this in your brain. Coefficient. 2 F's there. Coefficient. This is the number in front of the variable, and it is the numerical factor of the term. So again, 3 is multiplied by x. So technically, 3 is a factor of 3x, and x is a factor of 3x. Those are the two things that are multiplied together. They're factors. So the number part, the number factor, is the coefficient, and the letter part is the variable. Okay, so x is called the, what is it? Variable. Yeah, very good. 1 is the constant. Right on. Yeah, 1 is the constant. There's no variable attached to this number. It's the number in the expression that does not change, as I mentioned before. Okay, so this is really good. When you take these notes home, And again, in grade 9, not many of you probably do this out of habit or have thought of doing this, but you should read over these notes after we have these complete. Read over them to study them to try and memorize this, okay? Again, it's not just good enough to fill it out and forget about it until the next quiz or test. You need to try and learn this and memorize this. So these notes are excellent for you in that once we get them filled out, you just read them over. Go ahead and read them over after class. That's part of studying and learning, putting this truly into long-term memory. So read these notes over when you can. All right, so here's a note: an algebraic expression that contains a term with a variable in the denominator. And maybe some of you are forgetting what a denominator is, but if we have a fraction, the numerator is the number or the variable or the term or the polynomial on top, and the denominator is what's on the bottom. An example of this would be this 3 divided by n. So if you have a variable in the denominator, that is something special. That's a rational expression, and we're going to talk about that. I don't think in grade 9 here. We'll talk about that in grade maybe even 11. I don't know when we first really start to talk about that. But that's kind of a different thing altogether. As well, if we have a square root, so if we have the square root of a variable, such as the square root of n, so something like this, if we have a variable underneath the square root sign, this is also not a polynomial. So these are sort of non-examples of polynomials. And again, I'll explain why as we kind of move through math as we kind of go through this. But just a note, denominator or under a root sign, we're not going to count those as these polynomials that we're studying. Okay, questions? We good? Okay, you guys are with me? Good job. All right, types of polynomials. Let's talk about the types of polynomials. There are 3 general categories that we're going to be focusing on. Polynomials that have 1 term, 2 terms, and 3 terms. Of course, a polynomial could have, a billion terms. Just be different terms added or subtracted together, right? So we could have many, but we're going to focus on the first 3. And the specific names for a polynomial with 1 term is anybody know? Any guesses? Monomial, yes. Did you find that somewhere in your in the notes there, or did you know that? Oh, you know it as well. Good job, because I have that word in other parts of the notes later in the notes. So, yes, mono. So 1 term, mono, monomial. Okay, easy to remember. Polynomials. 1 term is mono, 1. So a monomial, that's a polynomial with 1 term. All right, what do you think a polynomial with 2 terms might be called? What is a word for 2 or a prefix for 2? Yeah, go ahead. Binomial. Binomial is absolutely correct. Good job. Binomial. So bi means 2, and so what kind of nomial is it? It's a binomial. Excellent. 3 terms now. What's the prefix for 3? There's probably more than 1, but what do you think? Trinomial. That's exactly right. Trinomial. Excellent. So we do want to remember these prefixes, and they all have omial at the end. So monomial, binomial, and trinomial. Like the tricycle or a triangle, 3. Awesome. All right, next page. Let's keep going. You guys are doing great here. Let's get some exercise here. So let's go through this and let's identify the following parts of these polynomials. Okay? So A, 3x squared plus 2x minus 1 is a polynomial. Okay, let's answer these questions. What is the variable or variables that you see in this polynomial? Just shout it out if you have an answer. Go ahead. X, right. Now, any letters that are in any of the terms, those are the variables. So they might be more than 1. So X is the variable that we see. Perfect. How many terms are in this polynomial? How many? Okay, 3 is correct. Why? How do you know it's 3? Because there's what, sorry? Okay, there's 3 parts to it. How do you know there's 3 parts to it? What is it that gives that away? There's something in between them, like an addition sign or subtraction. Very good, yes. If you have things that are added or subtracted, that means they're separate terms from each other, okay? The multiplied together, that's one single term. Anything that's multiplied together, that's one term. As soon as there's a plus or a minus, that means there's another term coming. Okay, so number of terms is 3, excellent. What are the coefficient or coefficients here? Remember, those are the numbers that are multiplied by the variable parts of a term, yeah?
3 and 2.
Very good. 3 right here and 2. So we'll just put 3 comma 2. Very, very good. Yes. Okay, this is a tricky one. This is a tricky one. What is the constant term or terms in this expression? Okay, all of you said 1. You're super close. This is the tricky part. It's actually -1. So you see how it's a -1 there? Technically, we'd have to identify, like if it was +1, what would you say? You know what I mean? If it was +1, would you say it was 1? And if it was -1, would you say it's still just 1? There has to be a difference there. So here, we're assuming all of these are positive, and that is true. But for the constant term, you have to include this negative in there. So the constant term is actually -1. Now, I don't want to confuse you or derail you, but you might want to consider when you're talking about the signs, like positive or negative, for these things, coefficients, constants, you might want to think of the polynomial as only addition. So it's like this term plus what? Well, this is like plus -1. You see that? If you think about this as plus -1, this right here is the same as this right here, then you would see, hey, that constant is a -1. So again, I don't want to confuse you on this one, but just remember, the signs that are before the coefficients or terms have to be included with the coefficients or terms. Okay, does that make sense, hopefully? And the type of polynomial, lastly, is? Very good, trinomial. Yeah, you guys are great. Okay. I'm going to do one more with you, and then I'm going to give you the third one to do in your own, and we'll see how you do. So one more I'll do with you. So variable or variables involved in this expression, they are x and y. Very good. I see an x there, I see a y. Perfect. The number of terms, how many? 2. Very good. 2. Excellent. Coefficients now. Coefficients. So what are the number parts of each of the terms? Or is there just one coefficient? What do you think? What do you see about in this one? What do you see? What would be the coefficient in this term? 6, right. Now, is there a coefficient in the second term, or do we say there's just none? What do you think? Well, it has a minus in front of it, so that might indicate something, that there's a minus in front of it. So minus what? What would the number part of this term be? Was your hand up? Oh, you're just stretching. Oh, you got to be careful not to stretch with me. I think you're putting your hand up. I'm just kidding. Do you want to try and answer? No. Okay. Anybody else want to try and answer? What's the coefficient to this second term? -3. Not quite. Again, you're on the exponent there. You really like exponents today. Okay. I appreciate your passion for exponents, but the 3 is the exponent part, which we're not really worried too much about just yet. That's coming. You're ahead of the ball game. Okay. Let me help you here. This actually, a negative or a -3, minus x cubed is what you would say here. This is the same as -1 times x cubed. So technically, our coefficient here would be -1. Yes. Okay. So coefficients of 6 right here, and technically -1 here. Okay. All right, now you'll hear me, and I would like you to also work at this. Maybe you've never actually been told about this, but when we're dealing with an operation that has a sign like this, that's a minus. when we're dealing with a number or a single entity term that has a sign like this in front, that's a negative. Technically in math. And I learned this a long time ago when I really actually understood this and learned this when I was interning like decades ago. And my teacher said, hey, you said -1. It's actually -1. I'm like, wait, what did I say? You said -1. It's actually, the term is -1 if you're talking about a -1. So the coefficient is a -1, technically not a -1. Okay? Now, it's just a little thing that I'll give you. That's for free. We'll work on that. That'll take some time probably for us to get our heads wrapped around that. But okay, what's the constant term? Ooh, that's a tricky one. What's the constant term? -1? Good guess. Not correct. 3. Good guess. Not correct. Let's go back and think about what the constant term is. It is a single number that does not have a variable multiplied to it that's either added or subtracted in the expression. Do you see one here?
Second x.
A second x. Good guess, but no.
Would it be 0?
Oh, it's 0. Yes, that is correct. What number are we adding to the end of this expression? Well, I don't see anything. That's the same as adding 0. There, no, you can't say that 0 is not important, because look at that. 0 is very important. So the constant term is 0. And for 0, you don't have to put a plus or a minus in front of it. You don't. It's just 0. Because it's really neither positive or negative. It's kind of both. So we don't put a sign for 0. Okay? Okay, very good. Now, the type of polynomial, again, another tricky one. The type of polynomial here. What would you say is this type of polynomial? A binomial. Okay. You guys agree with that? Okay, let me just play the advocate here. I see 1, 2, 3 terms here with plus 0. Does that make it a trinomial? Anybody think it might be a trinomial? You're like, I don't know. You know, not me. I don't know. Okay, watch this. Watch this. Does this polynomial now have 4 terms? How many terms could this polynomial have if I had time? Yeah, I could have near infinite number, right? There isn't actually an number that's infinity. It's just a concept. We can't actually write an infinite number of numbers because we can't have an infinite number of finite things. But I digress into philosophical reasoning for one moment. Anyways, the type of polynomial, we would consider all these plus zeros. We would only consider kind of the hard facts of the case here. So we wouldn't consider any plus zeros because we really could add as many plus zeros as we like. So this is a binomial, absolutely correct binomial. All right, I've done 2. Here's the third one for you. And I would like you to attempt to fill out this third one on your own go. I'm going to give you a minute to do that. And I will write out some answers in those blanks when you're done, and you can tell me whether you agree or disagree. Okay? Go ahead and do this one on your own. Okay, so this is what I have so far. Check your work and see if you agree with what I have down there, and see if you have something different, and if you think that something needs to be changed. And I'm going to get to that type of polynomial because I didn't tell you what type that is just yet. So I have the variables as being x, y, and z. Did you see those 3 there? Are there any more? I don't think so. The number of terms. So there's 1, 2, 3, and 4. There's 4 terms. The coefficients that I see there are 1 for this one. Let me just zoom in there a bit. 1 for the xy term, positive 1. This I can't count as a coefficient because there's no variable part, so I'm not going to count that one. I'm going to count a negative 1 for the z term, and I'm going to count a positive 2 for this x squared term. Okay? Anybody have all that so far? Ish? Okay, not a lot of hands. All right, the constant term was 6. Now, it doesn't have to be at the end. Usually the constant term is written at the end, but the constant term is 6. The type of polynomial, that was a bit of a trick question. We haven't talked about that one. Monomial, binomial, trinomial. Any guesses? This is a tough one, honestly.
Polynomial.
Oh, very close. Quadnomial. It's quadranomial. Yes, quadranomial. So that's kind of a bonus. You don't really need to know that one, but quadrinomial. I think that's spelled with an I. Quadra or quadri? Actually, I don't know that offhand. Quadrinomial. Quadri. I'm going to leave it as quadri. It might be quadra. Quadrinomial with an I. All right. A little bit of a bonus there for you. All right, moving on. Equivalent polynomials. Equivalent polynomials here in our notes. What are equivalent polynomials? Polynomials that have exactly the same terms, but the terms could be in different order. So when we add or subtract things, we actually could change the order around a little bit and still be the same. For example, 2 plus 1 is the same as 1 plus 2. You understand that? So in polynomials, if we just rearrange the order of the terms, they could be equivalent. So let's just do an example here. Okay, so if I had 2x minus 7, that's actually the same as negative 7 plus 2x. Okay, negative 7 plus 2x. Those are exactly the same. And what's important to note is that the signs, and I think I might mention this later in the lesson, but the signs that are attached to each term, they have to kind of go with the term if you move them around. Okay? So you see how the negative 7, that minus sign became the negative part there? And this 2x is positive, so that becomes a plus 2x. So the signs kind of have to stay. All right, degree of a polynomial. Degree. You guys are being very patient. This is a bit of a longer lesson here today, but lessons generally will be, 3/4 of the class probably, and generally how it will work, so you're doing good. The degree, okay, the degree of a polynomial. Now this is determined, the degree of the polynomial is determined by the term with the largest exponent or the greatest exponent on the variable or variables. So I'm going to put greatest, I guess, probably better than largest, but the greatest exponent or exponents on the variable or variables. So we are now really concerned about the exponents to determine the degree of the polynomial. And you will find in grade, probably next year, we'll explore different degrees of polynomials. Mostly in grade 11 and 12, we're going to talk a lot about the degrees of the polynomials and the characteristics that those polynomials have in their graphs and in their applications. So there's degree 1 polynomial you'll find is a straight line always. And so any straight line relationships, we can use a polynomial of degree 1. Degree 2 is a parabola, or it's a quadratic, and those have special applications as well. We use those a lot in math. So knowing what the degree is really important. So a degree 0 would be a polynomial where the largest exponent, now get this is a bit tricky to understand. If the largest exponent on the variable is 0. What kind of term would have an exponent on the variable of 0? What would that look like? Sorry, I heard something? A which, sir? A negative? Not necessarily negative. It could be negative, yeah. But what is the clincher about degree 0? So for example, let's just write 5x to the power of 0. Now, does that look a little funny to you? I mean, do you really ever see that? What does this actually mean when something has a power of 0? Does anyone know? Yeah, go ahead.
Isn't it just a number like times itself with
Okay, you're centering on the idea. Yeah, I heard someone else say it. It's 1. Yeah, a variable to the power of 0, or any number to the power of 0 equals just 1. I won't explain why that is right now. But yeah, any x to the power of 0, like this, would be 1. So that's actually equal to 5 times 1, or just 5. So a degree 0 would be a monomial that is just a constant. So it's a constant polynomial, just a constant term. That's what a degree 0 would be. Okay, so it's a constant, okay? Constant only. Degree 1 would be any polynomial that just has a 1 on its variable as an exponent. And of course, we don't really write the 1, just like we don't write 1 as a multiplier. Like you would never write 5 as 5 times 1 or 1 times 5. You just write it as 5. So it's kind of the same thing. We would just write this as 3x. This is preferred. Okay. Now, you also could have an example where we have 3x plus 10. That's also degree 1, because if you look at the exponents on the variables here, there's no variable here, or x to the 0, which is less than 1. So this is degree 1 as well. All right, degree 2, that's where we have something like x squared. And we also could have more terms as long as the exponent on the x is less than 2. So we could have 3x squared minus 5x plus 11 as an example, because the largest exponent on the variable is squared. I'm going to give you a, let's see, oh yeah, okay. I think I'm going to cover this in just a little bit. Let's see, polynomial. Yeah, I'm going to cover this in a bit. So degree 3, real quickly, would have some kind of variable. I'll use a different variable this time. How about a cubed minus a squared plus a plus 4 as an example. The largest exponent on the variable there in any term is 3, so this would be degree 3. Okay? Okay. Questions there? All right. So the degree of a monomial is the sum of the exponents of its variables. So this one's a little bit of a, this is the only tricky part of this. The degree of a single monomial is the sum of all the exponents of all the variables. So when we have a monomial such as 117 x to the 8 to the power of 8, the degree is 8 because that's the sum of all of the exponents on all the variables. There's only one. But if we had something like this, 117 x to the 8 y cubed z, much like that, just z to the power of 1, then what would the degree of this monomial be? Well, it would be, degree would be 8, because that's my first exponent, plus 3, it's my next exponent on a variable, plus 1, which would be the exponent on the z there. So what's that? That's a degree of 12. Okay. All right, we're almost done for today, so I'm just going to basically give you a couple more. We're going to work on a couple more things here, and then I'm going to give you a bit of a worksheet to start on here. So, polynomials. Okay, so polynomials, again, I gave you examples like this already, but let me just give you some more. If I had something like 2x squared minus x cubed plus 5, in this polynomial, what's the degree of this polynomial? Sorry? 3. Okay, does anybody else agree with 3, or do you have another idea? See some hands going up? Okay. Now, this one I deliberately tried to trick you just a little bit, because so far all we've done is look at the exponent on the first term there. But you remember that the degree is the greatest or largest exponent on any of the variable terms. So the largest one is 3. This is degree 3. You're absolutely correct. Great job. I wasn't able to trick you there. Okay. And really, it doesn't get any tougher than that. I mean, if we had, x to the 5 plus x to the 3 plus, and again, these are just examples with one variable only, plus 7, the degree would it be 5 plus 3, the degree here for this one? No, it would be only what? 5. Yeah, excellent. You guys got it. You guys got it. Okay, the last exercise, I'll do the first one with you, and then you'll do the last two, and then I'll hand out your worksheet for today. So, name the coefficients, the degree, and the constant term of each polynomial. Coefficients, degree, and, I don't have a space for constant term. What? Do you guys have a space for constant term on your notes there?
Yeah.
You do? Ah! Look at that. This is my formatting when I bring it into my notes here. It's on the next page, so that's really helpful. Okay. Whatever. You have it on your notes. That's great. So coefficients are, let's do this, -3, +4, and -5. Is that right? Anyone want to stop me before I mess up? Should I write -5 there? No? Yes? No? Okay, -5 is the constant, remember? So we're not going to include that on the coefficients. Ah, yeah, got you there. Okay, degree. What's the degree of this polynomial? 2. Very good. And the constant is what? Ah, close. 5? Thank you. -5. Perfect. Yes, yes, -5. Excellent. Excellent. Boy, you guys are catching on. This is great. Okay, please go ahead and do B and C here. And on your own, see if you can ace this. Because I don't think I can trick you anymore. I think you guys got it all figured out here. So you guys go ahead and do that, and I'll reveal the answers in a second. All right, go ahead and check these answers out for B and C. Anyone disagree with anything I wrote down there? Because I may have done something wrong, on purpose or otherwise. You never know. You guys are my double check. You should always double check your work. I usually just single check my work. Because if I make a mistake, I'm hoping you guys are going to catch it. Now, I don't think I made a mistake here, but does anyone agree with this, B and C? Let's go over it real quick. Coefficients on a variable term, so +2, and this is a variable term, that's a -1. Degree, you have to add the exponents here. So that's 1 + 1. The degree of this term is 2, so that carries the degree for the whole polynomial. Okay? So we didn't do an example like that. I want to see what you would do, but the degree is 2 here. Constant, +3. All right? Because here it is right here. It's a 3. With no sign in the front at the very first term, that's understood to be a positive. Okay? Finally, coefficients, just 1. That's -5. The degree is 1 because that's the largest exponent on any of the variables. And the constant is -6 right here, -6. You guys good with that? Yeah? Awesome. That's right. And just a reminder, on the website, mrmathwell.com, you can see a copy of your notes right here. If you need to print those out again, if you happen to lose them or whatever, you can print those out there. Also, this worksheet that I've just given you here, it's also on the website if you need to print another one out, okay? Any questions? Awesome.